Okay, let's look at the law of sines. So you have any arbitrary triangle A, B, C, then following equalities are true. A over sine of A, so ratio of A and sine of opposite angle is equal to B over sine of angle B and a C over sine of angle C, right? So let's try to pick on, say, this equality right here, right? Since a triangle cannot have more than one right obtuse angle, we have three cases we should consider, right? Case 1 is A and B are acute, right? Case 2, A is acute and B is obtuse or right angle. Or case 3, A is obtuse or right angle, then B is acute, right? So since case 2 is taken care of in the book, so this is in the book, so I'm not going to go over that. Let's try to look at the case 1 and the case 3. Right, so let's look at the case 3. Right, case 3 is actually this picture right here. Right, so what we're going to do is I'm going to draw altitude here. Right, then I'm going to call this guy H. Right, then we're going to say, right, so let's look at what would be, so this is case 1. Right, what would be a sine of A? Right, sine of A would be, so this is the angle, would be opposite over hypotenuse. So this is exactly H over B. Right, then if you look at the sine of B, this is going to be, let's see, opposite over hypotenuse. So H over A. Right, so this will give you that, say, multiply both sides by B, you get H is equal to, oh, maybe I should do it, B times sine of A is equal to H. Here, we multiply both sides by A, you get A sine of B is equal to H, right? So we can since both of them are H, we can set them equal to each other. So A sine of B is equal to B sine of A, right? Then we can just divide through by sine of A and the sine of B. We can get, so sine of B is cancelled out, so you have A over sine of A is equal to, sine of A cancel, B over sine of B. Right, so we could establish that inequality, equality there. Right, so that's the case 1. Right, case 3 is slightly different. So we have that, that's that. Case 3 is slightly different. So A is right obtuse angle. So we're going to have a picture which looks like this. Right, so angle A is greater than or equal to 90. So I'm going to draw it like obtuse angle. So here's a B here, and here's a vertex C. This is A, and this is C, and this is B right here, right? So what we're gonna do is I'm gonna draw an altitude here, right? So this is 90 degrees. So I'm gonna call this guy H, and call this guy C1 if we need it, right? All right, so let's look at, so we're looking at the case 3. All right, so if you want to find the sine of A, all right, so angle A is too big, so this is defined to be sine of 180 minus A, which is actually this angle right here, right? So it's going to be opposite over hypotenuse. You're going to get, let's see, opposite over hypotenuse. So this is actually H over B, right? Just like before, right? Then we look at the sine of B is equal to, so B is going to be acute, so it's going to be a regular. So opposite would be H over hypotenuse is A. Again, we have exactly the same situation as case 1. So doing the same algebra, we can get A over sine of A is equal to B over sine of B. So we could establish that equality there. All right, and between these two equality here, it's very similar, so I'm not going to go over that. So we can establish this equality as well doing the similar argument. All right, that's it. So this is law of sines, and note that this is true for any triangle. It doesn't have to be a right triangle. All right, that's it. I hope that this was clear.